everyone. I cordially welcome all of you to my presentation at 2022 IEEE Region 10 HTC Conference. I hope all the delegates, participants, and respectable professors are safe and sound during this COVID positions. Now, let's discuss my presentation. The title of my paper is the Smart IoT System for Automatic Detections and Protection from Indoor Hazard is an experimental study. Myself, Shahriar Kabir.
Now take a quick look of our presentation outline.
The introduction. So the IoT-based smart sensors and relays has been proposed in this paper. So beside the IoT-based systems is a safety mechanism also introduced for the consist of various sensors and built up with Arduino along with the monitoring mechanism. So the main objective of this research is to design the smart power relay operations in case of safety measurements. So in this research based project, we actually focused on three topics. First, microcontroller based Arduino systems, which is connected of several sensors, and secondly, the various sensors and relays has been for the safety mechanisms. So the key features of this was to collect the practical data and monitoring devices for remote zone and send the data in the cloud, and that these data can be analyzed and different places is using smart devices such as computer, mobile phone, and real-time detections. And for this detections, we can and the intelligence systems which can uh, operate from anywhere.
So the advantage of IoT. There are a lot of advantage of our project, such as the remotely monitoring indoor systems, indoor safety systems from anywhere using IoT, sound alarm systems if the smoke or LPG occurs, measure the monitor indoor values like humidity and temperature values and finally ensure the safety ventilation systems and ensure the electrical safety to intercept the power when the detect unusual values compared to the stand values in case of a small detector sensors. And this kinds of design and implementations of our project proposed systems at the indoor places and safety environment and monitoring to the all over systems is a certain period of time. So in the contribution part in this experiment actually ensure this experimental studies actually ensure the power safety and result of fire or gas hazard and IoT-based data monitoring systems has built-in actually continuously to monitor this kinds of leakages like LPG, carbon dioxide, ammonia from the surroundings. And the proposed systems has been planned for an online monitoring of the indoor safety measurements, and the parameters can be give for important as well as helpful information about about the environment and also the safety. So about the atmospheric record or kinds of security issues, also these kinds of things is this kinds of setup is important. This is the proposed IoT systems. So in here you can see the schematic circuit diagram representations. So all the sensors actually bring three pins and which are connected to common ground with the black wires. So the three gas sensors and DHT11s will get power from 11 volt Arduino. And MP180 is from 3.3 volt. So the Arduino powered up with 9 volt DC batteries, but we can also use Arduino USB cables to power up the Arduino board. So although the several sensors actually work differently, operated by different various voltages. So while the connecting the all kinds of sensors with the Arduino has setups into setup of analog input pins to connect it to all sensors. So there are two types of signals. So one can be digital signals and another was analog signals. So signals from the various sensors actually varied in voltages. In case this is Arduino, this is scale is about 0 to 255 to represent this voltage. So sensors simply record the all kinds of data and send it to the Arduino, so which is generated the signals into digital output. So we connect all sensors from with the A0 to A5 pins, A0 5 pins of the Arduino Uno. Black box back on the black box is the left bottom figure one. Actually, you can see that in here. You can see this is actually the 9-volt battery to power up the whole circuit. So this schematic representation is actually a representation of the fire suppression system, fire sprinkle systems, and relay modules is present about in it to the side the infrastructure. The Arduino board has been powered up the 9-volt DC batteries and Arduino USBs have been powered up with the Arduino board. So this guy's host models arise our batteries and DC supplies if there is inversion. So the proposed of this using various sensors data is actually is given here. So LPG and another natural gases are frequently utilized in residential and commercial places like hotels, restaurants, and CNG stations also. So in addition, LPGs have been utilized for residential and restaurant cooking area. No one can ensure that LPG cannot be leakage, and hence there's adopting the gas sensor systems is crucial and in real time gas system monitoring. In another hand, the gas leakage cause fires, which could be destroy for human lives and property. So this is actually the data we got from our systems. This is first was the monitored temperature data, and this was the humidity over the time, and this was the monitored of NH3 over time, and the last one is the monitored the air quality over time. This is the monitored LPG and flammable gas data. You can see that this all the things is measured in ppm, and this is the monitored smoke data. uh, and this was the CO data, uh, and this was the pressure data, pressure over the time data. This is the program flowchart. In this program flowchart, you can see that all kinds of data have been collected from the sensors, and according to the sensors data, um, there is an decisions have been given. So according to decisions, if the decision is yes, then is green light, and this is no, that means red light. In this red light, that means there has been some gas leakages, all kinds of uh, automatic shift systems has been activated. So in all, if this red light disappears, this all kinds of relays has been activated and disconnected powers. But all the data has been sent going to sent into the IoT platform to the users, and users can measure these data, and according to these data, he or she can apply his decisions. So also this is a control algorithm. This is the setup input and maintenance data and output. Here you can see that the implementation of this proposed systems. In figure 13, you can see that all of the sensors, some of the sensors actually have been shown here. So the result analysis. So this is actually the real-time data analysis. In here, you can see that the temperatures data, humidity data, smoke data, and CO data, and NH3's data, actually ammonia's data have been given and given. Actually, it's come from the sensors. So the result analysis. And this is actually the real-time data analysis, and since our proposed systems has been implemented in the indoor environment, so it is important to know about the energy consumptions of our systems. So it seems about 5,500 milliamperes per hour's power consumptions in totals. In presence is near about 5 watt per day are required to operate our proposed systems, and the cost of this component are necessary to complete this proposed systems about 32 bucks to build this prototype plan, which is affordable for this implementations. So at the conclusion, The primary objectives of this proposed IoT-based systems actually ensure the power safety due to the fire incidents or hazard gases. So when the smoke levels is crossing the threshold, at this moment the relay cuts off the powers and ensure the electrical safety. At this time, it could send the data to connected IoT platform and start its sounding safety sounding alarming systems so that the decision makings could be quickly. So this device could be bridge a gap between the physical and digital world to improve the quality of productivity, life, society, and industry. This is the references that I used. Here I conclude my presentations. Thank you very much for watching my presentations. If you have any questions, floor is open. Thank you.